This is the third of our lessons on time. In it, we look at the various forms of time used in order to cater for longitudes other than Greenwich. As we said earlier, by using an apparent solar day, we have a civil day which is of a constant length of 24 hours, with midday occurring approximately at meridian transit. The Earth therefore rotates one full rotation of 360 degrees with respect to the mean Sun in 24 hours. This is equivalent to rotation of 15 degrees of longitude in 1 hour, or 1 degree of longitude in 4 minutes, or 15 minutes of longitude in 1 minute of time. Local mean time, or LMT, is the time as determined by the mean Sun at an observer's local meridian. The datum for measuring the local time is the local noon, which occurs when the mean Sun is transiting that particular meridian. Here, as an example, the time at longitude 45 east is 1200 hours. Therefore, at 15 degrees an hour, the Earth will have to rotate for another 3 hours until the Greenwich meridian experiences noon. So the LMT at Greenwich must be 9 a.m. And similarly, longitude 90 east, which is 45 degrees further eastward, must have experienced noon 3 hours ago. Therefore its LMT must be 3 o'clock in the afternoon, or 1500 hours. We can therefore convert LMT at one longitude to LMT at another simply by the longitude to time conversion of 15 degrees per hour. Here we see local mean times at various longitudes going eastwards as far as the Greenwich antimeridian. We'll assume that the date at 45 east is the 16th of May. The Earth is at the centre of the diagram. As the scene is Earth-centred, instead of the Earth spinning eastwards, we imagine the Sun moving westwards. At 90 east, the LMT is 1500 hours. The Sun passed over it 3 hours ago. At 135 east, it is 1800 hours. The Sun passed over it 6 hours ago. And at the Greenwich antimeridian, 180 degrees east, the LMT is 2100 hours, still on the 16th of May. Now let's look at the same situation, this time going westwards. The mean Sun will not be overhead for another 3 hours. It must be 0900 hours LMT. But as we said last lesson, the local mean time at Greenwich is the definition of Greenwich Mean Time. So the GMT is also 0900 hours. We now use UTC, which for all practical purposes is the same thing. Continuing westwards, the Sun will not pass over 45 west for another 6 hours, because the change of longitude is 90 degrees. It must therefore be 0600 hours local mean time. And so on, until we get to longitude 135 west. This is 180 degrees west of 45 east, and so the time is 12 hours earlier, which is 0000 hours on the 16th of May, or, if you prefer, 2400 hours on the 15th. If we go a further 45 degrees westwards to the Greenwich antimeridian, we are 3 hours earlier. This takes us to 2100 hours on the 15th of May. But if you remember, it was also 2100 hours on the 16th of May when we counted it forwards, going eastwards. Therefore, local mean time changes date when crossing the Greenwich antimeridian. This is similar to the international date line, which follows the 180-degree meridian for the most part, with a few deviations. However, for LMT calculations, these deviations do not apply. Date changeover always occurs at the 180-degree meridian. The time on both sides of the meridian is 2100 LMT. but the date to the west is 15th of May and to the east is 16th of May. From the calculations we have just done, we can deduce the rule that applies when crossing the international date line. When crossing from west to east, add 1 day. And when crossing from east to west, subtract 1 day. Local mean time is not used for timekeeping and does not relate to anything we set on a watch because it changes as soon as we change our longitude. However, it is important because we use it as part of the calculation of the time of astronomical phenomena, in particular sunrise, sunset and twilight. We therefore need to know how to convert from LMT at one longitude to LMT at another, and how to convert between LMT and UTC. There are two methods, which are the tables in the Air Almanac and direct division of longitude. We'll start with the use of the tables. The first two columns are headed degrees and hours and minutes. Let's go to 15 degrees. The time beside it is 1 hour and 0 minutes. Now look at 16 degrees. This is 1 hour and 4 minutes. The first two columns go from 0 to 59 degrees. The rest, up to the grey dividing column, cover the remaining whole degrees up to 359. The columns to the right of the vertical divider are headed minutes of longitude and minutes and seconds of time. We know that 1 degree of longitude is 4 minutes. So if you look up 30 seconds of longitude, this corresponds to a time of 2 minutes and no seconds. Let's now do a practical example. We'll convert 137 degrees and 36 minutes of longitude to a difference in local mean time. Start with 137 degrees. What does this equate to? (137 degrees converts to 9 hours and 8 minutes of time. Now look up the 36 minutes. What does this equate to? (36 minutes of arc converts to 2 minutes and 24 seconds of time. Adding them together gives you 9 hours, 10 minutes and 24 seconds. In fact, for our purposes, the nearest minute is close enough. The second method is by simple division of the angle by 15, but it is easier if you use a scientific calculator with the degrees, minutes, seconds or DMS facility. The actual buttons to be pressed depend on which particular calculator you have bought. On this example, the DMS button looks like this. You start by entering the degrees. Press 137. Then press the DMS button. This little square appears. Then enter the minutes. Press 36 and then the DMS button. Finally, press divide 15 equals. This is a good deal quicker and easier than the tables, and it means that you can still solve these conversions even if the tables are not included as part of the exam. Now we'll look at some practical examples. We'll find the LMT at longitude 103 degrees and 55 minutes east, which is in Singapore, if the UTC is 0800 hours. Your first step is to convert 103 degrees and 55 minutes of longitude to time difference. Work it out by one of the methods shown in the last scene. You should have got the answer: 6 hours, 55 minutes and 40 seconds. We'll call that 6 hours and 56 minutes. The next question is the LMT going to be an earlier or later time than UTC? Look at the diagram. The Earth is spinning eastwards. Does Singapore transit the Sun before or after Greenwich? The answer is obviously before. So the time in Singapore will be later. 0800 hours plus 6 hours 56 minutes gives us a local mean time of 14:56. Note that in the table we have a column for the date, as well as hours and minutes. We do not need to use it for this calculation, but get used to putting it in as a matter of habit, because it is sometimes essential. When working out whether LMT is earlier or later than UTC, you can use the rule longitude west, UTC best, longitude east, UTC least. Another useful rule is that when they're having breakfast in New York, it's lunchtime in London and tea in India.